Hello, and thank you for watching our collaborative presentation on the use of community-owned monitoring networks to establish baseline data and support comprehensive understandings of air pollution impact in the Ohio River Valley. My name is Ben Hunkler, and I'm a community organizer with Concerned Ohio River Residents. My family's Ohio Valley roots run 7 generations deep. But in the last 10 or 11 years, the region has been scarred by oil and gas-related air pollution. The landscape is riddled by hundreds upon hundreds of hydraulic fracturing wells supported by a pervasive network of pipelines, compressor stations, waste injection wells, and other oil and gas infrastructure. Pollution emanating from these facilities poisons our air and communities. We're here presenting today because our regulatory agencies have done little to stop it. Belmont County is the most heavily fracked county in the state of Ohio, with more than 590 producing wells. Yet the county has only a single US EPA monitoring location in Shadyside, providing baseline monitoring. This one monitor does not provide the spatial or temporal coverage needed to monitor sudden local spikes in emissions that can impact the health of local communities. Across the valley, an insufficient number of sanctioned air monitors paint an incomplete picture of the current extent of air pollution suffered by frontline communities. And when permitting new facilities, state regulatory agencies fail to account for the cumulative impacts of air pollution emitted by nearby oil and gas operations. Our group's efforts to provide low-cost monitors to impact residents in the Ohio River Valley seeks to rectify these problems by creating a grassroots, public-facing, and community-owned monitoring network to establish baseline data across the valley, giving residents and regulators alike a more comprehensive understanding of regional air pollution and its public health ramifications. Air quality is threatened in the communities living near oil and gas operations due to increased pollution from methane and volatile organic compounds, or VOCs, which scientists associate with a range of health problems, from throat aches and nausea to asthma and cancer. Concerned Ohio River Residents has met personally with dozens of folks from frontline communities whose mental and physical health has suffered as a result of their proximity to oil and gas-related air pollution. They're sick and tired, and many times they don't know where to go for help. That's because the Ohio Environmental Protection Agency, the state regulatory agency tasked with ensuring Ohioans are protected from hazardous air emissions, inadequately regulates fossil fuel-related pollution and offers very little recourse to communities impacted by oil and gas development. The frontline residents we've spoken to are desperate for any actionable means to mitigate their exposure to harmful air pollution. The emissions from fracking infrastructure are constant and inescapable, and the state agencies in charge of regulating this pollution neither proactively restrict it to non-hazardous levels nor retroactively respond to citizen complaints in a reliable and timely manner. These folks' lives have been upturned, and no one is stepping in to help.
My name is Garima Raheja. I'm a Thriving Earth Exchange Community Science Fellow, as well as a PhD candidate at Columbia University studying air pollution. I'm going to be talking today a little bit about injection wells. Dismantling of important regulation like the Niehaus Law, which took away local control over the industry in Ohio, has been allowing heavy industrial polluters in otherwise residential areas located next to homes and schools. We are also concerned about emissions from injection wells, which require no air permits, but clearly emit harmful pollutants into the air as seen in this video. Let's take a look at this clip from the Silcore injection well in Guernsey County. From this video from Earthworks, you can clearly see proof that emissions are coming from this site, and local residents have suffered headaches, fatigues, and burning sensations in their throats and noses, but injection wells like these need no air permits and therefore are not considered when calculating the cumulative emissions or impacts from fracking operations. Despite the rapid rise in fracking operations across the Ohio region, we continue to see a stark lack of monitoring by the EPA. So on the left here, we have a map of the frac laterals across the state, and you can see how they have been rising in the past 10 years. On the right, we have a map of the 3 reference grid air pollution sensors in the region. So you can see how localized air pollution is not captured very well by these monitors, and therefore we have set up to install our own low-cost air pollution sensors in residents' homes and neighborhoods to measure the concentrations of particulate matter in the air that we breathe. As we are trying to understand the air in Belmont County, we're also taking a bottom-up approach, starting by understanding the amount of emissions that each industrial site is allowed to emit into the air, and then understanding the cumulative impacts of all of the sites put together. Of course, this information is not often provided easily. To get this information, we went to the Ohio EPA's website and searched for all of the permits, revisions, and issuances that were granted by the agency. Then we downloaded each of the sites permits, which are 20 to 80 pages long. And then what we were looking for is just a line of this that clearly states how much of these pollutants can be emitted in a year. We did this just for the first half of 2019, and you can see that cumulatively, just in these 6 months, the Ohio EPA permitted more than 343 tons of carbon monoxide and 1359 tons of volatile organic compounds to be emitted each year for the rest of the time that these sites are operational.
Understanding these gaps in the EPA air quality monitoring network that has been highlighted here, concerned Ohio River residents and freshwater accountability projects sought and received funding from the Community Foundation of the Alleghenies to support a community-owned monitoring network. The network consists of AirVis Inc. Monitors that measure total VOC and PM 2.5, and Purple Air PM monitors, some also with VOC add-ons. These monitors have been strategically placed by expert citizen scientists throughout southeastern Ohio and in the highly industrialized Ohio River Valley at varying altitudes, at close and far proximities to major air pollution sources, as well as at indoor-outdoor comparison sites. This kind of comprehensive planning for data acquisition is intended to indicate to the Ohio EPA and industrial polluters where gaps in pollution controls are, and where reference monitors may be useful corroboration of the public health impact that communities have documented in complaints to the Southeast Ohio EPA office. Although ideally, enforcement of health and clean air standards could be upheld based on data analysis from this network and resulting air sample collections.
As Anna pointed out, the concerned Ohio River residents have set up this extensive network of monitors, and that is in addition to 3 key monitors that the EPA is maintaining in the region. And these 3 monitors monitor for NO2, for ozone, for fine particulate matter, PM 2.5, and for SO2. So the addition of monitors for the VOCs and a better spatial scale of particulate matter are really helpful for understanding the extent to which terrain or weather or other aspects of the region can impact the spread of pollutants. Over here, what we can look at is some modeling that we've done to look at the pollution and the spread from a given point source of emissions in the region. And this is the percent likelihood that you would find pollution in the area. And so what we can see is kind of this trajectory and how much of it really is staying close by in these red and yellow circles versus spreading out into these more blue or green regions. Now, a combination of modeling and monitoring is ideal in order to be able to understand the impact of emissions and of pollution on the region, because it gives us a much better understanding of the spatial extent and the spatial differences. Modeling has to make a number of assumptions about weather. It simplifies some of the chemistry often, and may not always include every potential source of pollution. And so having a extensive network of monitors is really helpful for understanding that as well.
For this portion of the presentation, we will be discussing a citizen air monitoring program that we launched in the fall of 2020 near Salem Township, Ohio. 2 monitors were installed at residences that were located within a half-mile of major infrastructure, such as this compressor station, active frac pads with laterals that run underneath here, pipelines, transmission lines, and gathering lines, valving stations located here and here, all potential sources of emitted volatile organic compounds. Also not shown in this are waste disposal wells just outside of this area within a couple of miles, waste disposal wells, landfills accepting drill cuttings and waste fluids, and also abandoned coal mines that underlay this area here. The responses of these monitors show very similar trends from the 2 homes with regard to their outdoor air quality. And you can see these the correlation of peaks. The magnitude of these peaks could be different for a number of reasons: distance from the site, wind direction, and other atmospheric conditions. some of these days detected over this past year or half year or so, we saw values reaching 4,500 parts per billion for total volatile organic compounds in outdoor air quality. We were interested in also measuring the indoor air quality of these homes. So we moved one of the monitors in and we saw a rise in the background level of volatile organic compounds within home, which is not surprising because there are lots of potential sources within home, cleaning agents, preservatives like formaldehyde on furniture and other things that are present indoors. But what we really were concerned about were these very high peaks that would last for hours and in some cases days. And in one case, in the middle of the night, this is midnight on this day, we had values that exceeded 6,500 parts per billion for volatile organic compounds. This time correlated with health effects experienced by the homeowners, waking up with severe headaches and runny noses and eyes. They contacted me at night to request some guidance, and I said that they should evacuate their home and also open their windows, which they did. And you can see at this point, there was a rapid decrease in the indoor air quality with regard to total volatile organic compounds. They were out of the home for about an hour, returned, closed the windows, and then the concentrations quickly rose to those that were previously being detected. We used profiles like this from our VOC monitors produced by AirViz to indicate sampling times for both good air quality and bad air quality, and then collect those samples, send them off for analyses, and this table just quickly summarizes what we observed. In the good air quality samples for outdoor, we detected basically none of the 30 or so VOCs that we're measuring for. On bad air quality times, the outdoor, we detected acetone, these CFC11, CFC12, and 2-butanone. Indoor air quality, even on good air quality days, we detected values of ethanol that were at least 100 times over the regulatory limits. And on bad air quality days, very high concentrations, very, very high concentrations of ethanol and acetone were detected in the home. And for indoor air quality, for those things that we measured that were at least 10 times over the regulatory limits, on good air quality days, we did detect acetone. On bad air quality days, we detected ethyl acetate, toluene, N-butyl acetate, 1,2-dichloroethane, compounds that are commonly associated with oil and gas infrastructures and processing. Our future research directions include identifying the sources of these environmental contaminants and describing and confirming potential subterranean migration routes of fugitive gases into the home. So things like underground utilities, where the utility is packed in sand and have higher diffusivity of materials are known migration routes of contaminants coming into homes. We're also going to be looking at similar things with regard to pipelines and even possibly the abandoned mine caverns in this area. We intend to characterize the impacts of things like topography and atmospheric conditions on the regional fate of industrial emissions. Do these heavier than air emissions funnel down into valleys and impact people that might actually be 10 or 20 miles away from a site? And we intend to enhance communication of scientific results with industry and regulatory agencies who are committed to protect the health and welfare of citizens and the environment.
I'm Leah Harper with FreshWater Accountability Project and want to thank the 2021 Shale workshop organizers for the opportunity to share this webinar and to communicate our results as part of the project with the American Geophysical Union's Thriving Earth Exchange program. We have 3 benefits that we have outlined as a result of our research so far, and also a couple opportunities for further research that we'll probably be expanding upon that we wanted to share with you. We invite you to get in touch with us for further information. This is my contact information for the project. And then once again, thank everyone who's participating in this project, and especially our funders and the people who invited us into their homes and have helped us with this research.